It's often useful to run TSO commands or command lists, known as clists, in a batch job step. Let's see an example. Here's a TSO clist version of our Hello World example, which by now should be pretty familiar. It reads a list of names from a QSAM dataset and writes out another QSAM dataset that says hello to each of the names. Key elements of the JCL are the DD statements that simulate terminal input and output. Those are the systsIn and systsprint DD names. The sysproc DD statement tells the system where to find our clist. Those are the DD statements in this example that are pertinent to the TSO batch execution environment. The names and greets DD statements declare our own input and output datasets. Note the program name is not the name of the clist. It's the name of the Terminal Monitor Program, or TMP. Its name is IKJEFT01. There are two additional entry points we could use, IKJEFT1A and 1B. They are out of scope for this course, but they are not very different from IKJEFT01. There's a summary of the differences in error handling behaviors in the slides in your handouts. The Terminal Monitor Program sets up an execution environment that looks like it's interactive from the point of view of the clist. We can run our Hello World Rex script the same way. Here it is. And here's the JCL to run it in batch mode. Notice how similar the JCL is. The greet step executes the Terminal Monitor Program and passes the name of the Rex script as a parm value. Instead of sysproc, we provide a DD statement for sysexec. That's the library where the Rex script is located. There are systsprint and systsIn to simulate terminal output and input respectively. The input and output DD statements are for our own input and output datasets. Rex can also be executed in batch mode using the IRXJCL utility or the IRXexec routine. Both are TSO-based interfaces to the Rex interpreter. Here's our Hello World Rex job substituting IRXJCL for IKJEFT01. Notice there are no changes except the name of the utility on the exec statement. Basically, anything that can run in the TSO environment can also run under TSO batch. In addition to clists and Rex scripts, this includes ISPF dialogues, query management facility queries, and applications that access DB2 or IMS database resources. This does not imply you must use TSO batch to run all these different types of programs in a batch job. But you can use TSO batch for these various things, and you will probably see examples of JCL in your real work that are set up this way. When the application is relatively simple, using TSO batch in a job step is a straightforward way to execute a program that uses TSO facilities. Here's an example of JCL to run a batch application program that accesses DB2 resources. For more complicated applications, TSO batch may not provide sufficient recovery support. Facilities like DB2, IMS, MQ, QMF, and VSAM are resource managers. A resource manager knows how to coordinate concurrent accesses to its own resources and how to recover from failures. But many applications use more than one type of resource. No single resource manager can coordinate accesses and recovery across multiple types of resources. For that, we use the Resource Recovery Services component of ZOS. Its job is to manage concurrent access and recovery across multiple types of resources. Each resource manager follows certain conventions so it can work with RRS. An application that uses a managed resource like DB2 or VSAM or MQ connects to each resource manager using an attachment facility or AF. The reason many applications run in TSO batch is that TSO has an attachment facility for each resource type. Apart from that, a typical batch application has no need of TSO resources. It's convenient to use TSO batch to get access to the AFs, but the downside of running applications that work with more than one resource manager through TSO batch is that RRS is not able to manage access and recovery globally across all of them. When an application program reads QSAM datasets and updates a DB2 database, the TSO AF is fine. But if the application reads QSAM datasets and updates DB2 and VSAM and puts messages on a message queue, then we want to use RRS to coordinate resource recovery in case of a failure. This is the preferred way going forward for new applications and for modernized legacy applications. When it comes to DB2, another reason to prefer the RRS-AF is that it's necessary when executing stored procedures written in a high-level language like COBOL. Here's SampleJCL to execute an application program that connects to DB2 via the RRS-AF.